Welcome everyone. Welcome to the session Cloud Native Applications for .NET Developers. There are a couple of, before I start, first of all, thanks to the WadaStack management and organization team. Great conference, and thank you for the opportunity. About the title, each word in the title means something, so that's why it's tailored like that. Before I start, a bit more introduction about myself. 18 years .NET love and hate, technical director at Init Group. I consider myself servant tech leader because my job is to make the teams that I work with as efficient as possible. I'm also Microsoft MVP starting 1st of September this year for Cloud Native and .NET. And I'm supposed to be a very relevant person for this topic, but that I have to prove it now, actually. Married and father of 2, and yes, you heard about the mountains. The agenda for today is what are cloud native applications in 2024 and beyond, benefits and challenges, case study and some source code, and then conclusions. It's a kind of a very wide topic, so stay with me. We have to start very wide, and then we have to go deep dive into something very concrete and very detailed. So it will be a nice journey, I expect. Okay, cloud native origins. In my career, this is the third term that I'm facing now. It started with, before 2016, with cloud-enabled applications. Then 2017, born in cloud was the cool word, and now we have cloud native. What's the difference? Cloud enabled, it's very simple. It's lift and shift. So you take whatever you have and you put it in the cloud. Whether it's VM image running with your software and then running in cloud, that's cloud enabled. Whether it's monolith containerized and put into cloud, that's also cloud enabled. Then we go to 2017, born in cloud. The product that I was involved or I was developing that time, even the marketing material for that product was born in cloud. What is literally born in cloud? Meaning it means vendor lock. So you build your product that much connected to the cloud provider that you actually cannot run it anywhere else. So it is kind of bad definition, but that's just for you to understand it, what is the clear difference between cloud-enabled and born in cloud. And then we go to cloud native, which is the definition for today. And cloud native is none of these two. So it's not monolith running in container in cloud, but it's also not vendor-locked solution. So we're still talking about cloud, but in a good way, in a positive way. As a matter of fact, cloud-native applications, there is very simple definition for it. If you have microservice architecture or distributed systems that run on containers, and you have a very efficient DevOps pipeline so that you can release your source code whenever you want and as much as you want, and you have a very good agile team behind that, so you can support this process, then probably you are doing cloud native application. And this is the Wikipedia definition, and in my opinion, it's probably the best one. So it's not coming from cloud vendor, so it's not biased definition. Another very important thing is that your cloud native application has to be portable. So you have to run it on whatever cloud provider you choose, including private cloud, which means on-premise. So in my opinion, the true definition for cloud native is that your solution is really portable. You can run it whenever you like. And that's why I said vendor lock is not the real definition for cloud native. And also monolith is not really cloud native application because you don't benefit from the microservice architecture. That is resilient services, loose coupled services, faster development, faster release. If it's that simple, why do we have this session? Why do we talk about cloud native? If you all do these things, right? If you all have agile team, if we have DevOps, and if we do microservices, what's the deal? Well, this is the deal. This is the Cloud Native Computing Foundation, established 2015, and they are actively building tools, frameworks, semi-frameworks, semiconductors, adapters, whatever you want, to make this process much easier. So there are plenty of tools that can help you build cloud native applications. And then you have to choose what works for you, what's the best for you. You are an architect, team lead, engineering manager, whatever you are. You are a decision maker that you have to make certain decision to deliver a solution, and then you have to live with that solution because you have to make the right choices. You have to make certain selection and you have to live with that. That's why the cloud native and this session is coming into place to help you make the right decision, because you don't always have all the options available, meaning you don't have enough resources, you don't have the right resources, and so on and so on. Just to illustrate that situation, I mean, just imagine you have microservice application and you have to host it in Azure. And you have like 3 to 5 or 10 Docker containers, and you have to run it into cloud. What are your options? How can you do that? So this is just a short list of the options. I'm sure there are at least 3 more that are not on this image. Going to the left, you go to more complex use cases, which will require much more orchestration. And when I say orchestration, I mean Kubernetes. Also, if you go to the left side, it means more costs. If you go to the right side, you have simpler use cases, which means less orchestration. That doesn't mean less Kubernetes, but means abstraction over Kubernetes. So you don't deal directly with Kubernetes, but someone else is taking care of that. In this case, it's Azure. And of course, if you move left, you go to cheaper solution. So what would you choose? Let's say you have infinite budget and you have 3 Kubernetes ninjas in your team, then probably you can solve all your problems with Kubernetes service cluster. But that means that you need at least $300 for single Kubernetes cluster running in cloud, and you also need to have these ninjas in your team. But what happens if you don't have them? Like if you have just €50 per month for your product, and you don't have Kubernetes knowledge in your team, what would you do? Therefore, we have all these tools, frameworks, adapters, whatever however you call them, to help you in that process. So even your core full stack development team, like 3 .NET and 3 Angular developers, can actually do that for you. The only goal for cloud native is basically to increase the efficiency, and not the efficiency of your solution, but your efficiency of your team. So basically, you don't select any technology that will make your life harder. It has to make your life easier, and you have to be faster. So that's the only goal. Why do we have this plenty of tools available to deliver cloud-native applications? The second thing is cost reduction, because we are talking about cloud, and everybody expects that the cloud is cheaper. I doubt that. There are cases when the cloud is not cheaper than on-premise. It's very contextual, and it depends. I would stay there. That's the answer. And of course, ensuring availability, that comes from the cloud. You have almost infinite scalability, you have almost infinite resources, or at least in theory. So technically, resilience, auto-scaling, all that stuff, and that comes natively from the cloud. So basically, yes, you can ensure high availability of your solution. You can do that on-premise as well, but then you might have cost issues. It's not that easy, definitely. There are challenges. So imagine you have your full stack team working on ERP solution and developing monolith software for 5 years, and suddenly you have to distribute that. So the distributed systems and microservices, they come with some complexity behind. First of all, cognitive complexity, you have to understand them. You have to learn new technologies. You have to understand how to run it locally and how to run it in cloud, and that comes with price. So technically, that complexity of distributed systems transforms into the local development complexity, and also transforms into the learning curve. Also, we have monitoring on observability on top of that, because you might run a couple of microservices locally, and then the rest runs in cloud, and then you have to do the root cause analysis, or you have to trace all the events. That comes with some complexity. And of course, you still have to stay away of vendor lock-in. It's very easy. It's very easy that you just pick up 5 Azure services and you lock in your solution there. It's nothing wrong with that, but you have to be aware of it. Okay, enough theory. A very simple cloud native application. This is deployment diagram. This solution runs in cloud, in Azure. We have 3 microservices. The first one is, come on, ingestion service, responsible for receiving HTTP requests. Then it sends all the requests through queue to transformation service. Then we have some business logic, business magic happening here. And then we send it over again to the next queue. And then we do some extraction knowledge with OpenAI. All these 3 services, they have to know how to talk to Cosmos DB, to store the data there because they are stateless. And of course, they have to know how to send and receive data from the queues. Is it really cloud native application? Well, I just denied myself. There are a lot of cloud-specific services here. So it looks like there is a vendor lock-in already on this diagram. But that's not my point, so I will just skip that part. Let me quickly show you the source code for this solution. I'm talking about microservices, and by definition, microservices, they have to run in their own repo. But for the sake of this demo, I have them into a single repo in single solution. In practice, it shouldn't be like that. Each microservice has its own repo, own DevOps pipeline, so you can run your code without affecting the rest of the microservices. For this solution, we have one API project, which is actually the ingestion service. Then we have transformation service and extraction service. And we have 2 more projects. One of them is common service, which is basically implementation of queue communication and storage communication, and domain model for the entities. What is important here is, what I want to emphasize is basically the Docker Compose file, which makes the local development actually easy for the developers. So we have one DevOps engineer writing down this Docker Compose file for the team, and then all of them, they use it. And that one is also quite simple. I will just. So we have 3 Docker files, 3 services described here. It's very simple. There is no service invocation, no orchestration, no dependency. They are loose coupled because they communicate over queues. So it's quite simple. Any questions maybe for the solution? The idea is that there are no questions. It's very simple and it works. Okay, going further. How can we improve this? It depends on the team behind. Is your team comfortable with this kind of solution and with these technologies? If that's okay, you don't have to do anything else. You're cloud native from the beginning, and that's it. You don't have to learn new technologies. You don't have to do anything else. But what if your team is not okay with this type of approach? What if your team doesn't know Kubernetes? What if your team doesn't know Docker Compose? What if you have to expand this solution with 10 more microservices and then service invocation and maybe reverse proxy in front of it, like authentication gateway and so on and so on? Then your Docker Compose file, it will become much more complex, even not suitable, so that you have to switch to Docker Desktop Kubernetes. And then there is an old saying, if you have one problem and you solve it with Kubernetes, you have 2 problems if you don't have ninjas in your team. So technically, that's one of the challenges that you might experience with this team, with this kind of solution. Another challenge is the DevOps. Behind this, we use YAML files and Azure pipelines to release this solution to to production and to all the environments. And that also comes as a question for your team. Is your team good enough to work with these technologies? Now we come to the possible solution, .NET Aspire. .NET Aspire is cloud-ready stack for building observable, production-ready distributed applications. .NET Aspire is not framework, it is not SDK, it's not runtime API like Dapper, it's not a single library, it's all of this. So that's why it's called stack. That's the first thing. And another thing that is not mentioned on this slide is that .NET Aspire is opinionated stack, meaning the team behind .NET Aspire gives you their own recommendation on which technologies to use and how to configure, but everything is open for change. So technically you can use it as it is, but you are absolutely free to change all their recommendations. One very important and one very good thing, or it's up to you to decide whether it's good or not, but the main difference with .NET Aspire is that you get your application, your microservice topology in C#. No YAML files, no JSON files, no config files, no Docker components, nothing. You build your configuration, you build your microservice architecture with C# code. And that's why the title of the presentation is basically Cloud Native Applications for .NET Developers. It comes with built-in orchestration. So you add you define your microservices with C# code, and then you have orchestration out of the box. There is also service discovery out of the box. In our case, we use queues, but if you have to invoke service from one to another, then there is a built-in service discovery. Very nice thing is the central dependency or service injection, which means source code reduction. For instance, all my 3 microservices, they have to know how to connect to service bus. And they have a connection string, they create service bus client, and they inject that into all the services inside. With this, technically, we can create one single definition, and then the root, the .NET Aspire root, actually will inject that dependency in all the services where it's needed. So on long term, it reduces the boilerplate source code, which is a very good place for technical debt and bugs. It comes with some built-in DevOps support, which also, it's good for start. On long term, your DevOps team will not be happy with that. At least that's my impression so far. And it comes with dashboard that gives basic observability. So technically, when you run the solution, you get a dashboard with services, their health check, trace analysis, and so on and so on. Let me show you that. Come on. It's a bit risky changing, switching branch live, but yeah, bear with me. What's the difference in the new project, in the .NET Aspire project compared to the previous one? And that is we have 2 more projects in the solution. The first one is application host, and the second one is service defaults. Application host is basically your new Docker Compose file. This is where you define your services and your topology. And then I will show it briefly. And then we have the service default, which basically configures all these opinionated functionalities like observability, service discovery, and so on and so on. I will just turn the magnifier off, and I will show you the source code. So technically, in the application host, we have the same thing that the Docker file is actually, the Docker Compose file is actually doing, and that is defining all 3 microservices in C# code. So this is equal to your Docker Compose file. That's the first thing, and I will also quickly show the come on. The extensions, I haven't done any change here. It's intentionally clean as it is. You get the configuration of OpenTelemetry exporters, default health check, and also say it service discovery. We can run this solution. I haven't run the previous one, but we can do this one. The good thing is that from the previous one to this one, you have to do 3 clicks. Right-click, add .NET Aspire orchestration support. So that's okay. I missed the approvals. That's my company security. Sorry. Nope. I assume someone else is using the same, meaning the Docker container running in behind. Nope. Okay. I will not going to debug that now. What I was going to show you is the dashboard that comes out of the box for free when you have all these 3 services with the health check and also trace analysis. Going back to the presentation, what is my personal experience? Definitely with .NET Aspire, there is some learning curve. So it doesn't mean if it's .NET that you will just go into it and use it out of the box. It's still very complex, a stack of components and services inside. The good thing is that you still stay in .NET and C#, so you don't change the stack or you don't go into DevOps if you are allergic to that. Maturity is still under question. It's generally available since May, I think, but in my opinion, it still lacks a lot. So if you want to use it wisely, or first give it a try and then consider it for real projects. And the main idea behind .NET Aspire is the source code vs config philosophy. It's not good or right. It's what works for your team. It's same like we have the Pulumi and Terraform or Bicep. Pulumi is infrastructure as a code in C#. Bicep is infrastructure as a code in JSON, YAML, and then transforms into ARM templates into JSON. You get the same result. It's up to you to decide what works for you the best. What kind of team do you have behind? How can you support this process with your team? That's it from me. Yeah.
Thank you, Miroslav, for your presentation.
Thank you.
Thank you for pointing out the difference. A round of applause, please.